Hi, physics. Again, we are talking about projectiles. You've just completed the projectile lab where we shot off a penny off the edge of the table, and we also had one free fall. Okay, and we were looking at the trajectories, seeing what the path was, the trajectory. Okay, and noticing that it has a specific shape. It has a shape of part of a parabola. Okay. Anyway, will they? We tested a couple of questions. Would they land at the same time if we used more or less force? We didn't always have the best testing method there because we would have some extra spin on the pennies and it wasn't perfect, but basically we found that if you use more force, it would land at the same time. Okay, what if the pennies were projected from a higher or lower surface? We did that also. And we found the same findings again. And that was pretty exciting because that's how it's supposed to go. And so when we did that, I think that most of us that we were pretty sure that we thought how it landed, but let's look at some of the math involved in it, and let's also just look at some of the ideas involved in it. Anyways, they both land at the same time. The only thing is different is that one is being pushed out horizontally. So that tells us that there's a lot that is similar with the vertical motion of both the coins. In fact, it should be identical, especially if they land at the same time, right? Anyway, so let's look at some of the motion. When we look at this motion, here's a great diagram that I found off of the internet where it displays how that when a ball is projected out and another one is free falling, watch this. Before you write anything, please watch. Okay, I am taking the same exact arrow. I copied and I pasted it. It is the same exact size all the way across. So that is telling us that the horizontal motion, that it is identical, that it doesn't change. And basically, you know that we talk a lot about physics without friction, but this is really close to actual. Anyway, notice that the horizontal speed never changes. Therefore, the objects are not accelerating at all horizontally. We know, of course, though, however, that they will accelerate falling downwards because everything falls to the earth at what rate? At 9.8 meters per second squared. So every second is going 9.8 meters per second faster. And so the vertical forces are identical as each other, as both the projected one and also the one that is free falling. They're identical to each other, which helps explain why they landed at the same time. Okay, we can analyze projectiles and then we can analyze them vertically and horizontally. We can do it separately. We have to do it separately so we can understand all the motion. Anyway, back to our lab. We had, I want you to draw the trajectory. So try that here for a second. You might have to press pause. Draw the one that's free falling and the next penny that you projected out from the same height. What would it look like? We pretty much just drew that on the last diagram. Okay, and then what would happen if you also put on the same drawing the same coin but projected out faster? You would get a farther projectile, one that had a longer range, one that went further from your first frame of reference that hits the ground there at the free fall and goes all the way over to the other one. Anyway, there's a longer range now because you had a much faster projectile. There's an old picture in textbooks that show this right here. I've seen it many times in many different textbooks, and this is also showing how the projectiles in real time with a camera is showing how that they do fall at the same rate. I've seen that in many textbooks. Anyway, here's another projectile, isn't it? What other ones can you list in your notes? Bring that to class tomorrow. I'll be excited to see it. Here now, we're going to stop this. Oh, wait, we're going to go on and talk about, yeah, we're going to stop this video now, sorry.